Rusting happens when iron reacts with oxygen and water, and it's an example of a chemical change because a new substance is formed.
When iron is exposed to air, the oxygen starts reacting with it. If there is also water or moisture, like rain or humidity, the reaction happens even faster. The iron loses electrons and combines with oxygen to form iron oxide, which is what we call rust.
Rust looks reddish-brown and flaky, and it's actually weaker than iron, which is why rust can damage things like cars, bridges, and fences over time. This reaction is called oxidation, and it's a type of corrosion.
Overall, rusting is a slow but important chemical reaction that shows how materials can change when they interact with their environment.
Next, we're going to be explaining the chemical reaction behind a homemade lava lamp using vegetable oil, water with red food coloring, and a fizzing tablet.
When we pour the vegetable oil and the colored water into a container, they don't mix. This is because water is more dense than oil, so the water sinks to the bottom while the oil floats on top. The food coloring mixes with the water, not the oil, which is why the water stays red.
Water molecules are polar, meaning they have positive and negative ends that attract each other. Oil molecules are nonpolar, so they don't have charged ends. Because polar and nonpolar substances don't mix, water and oil separate.
When we drop in the fizzing tablet, it reacts with the water to produce carbon dioxide gas. The fizzing tablet contains an acid and a base that react when they dissolve in the water. This reaction creates carbon dioxide gas, which forms bubbles in the water. The gas bubbles attach to the colored water and push it up through the oil, making it look like a lava lamp.
Overall, this experiment shows how density, polarity, and chemical reactions work together to create the lava lamp effect.
Finally, we're going to be explaining the chemistry behind making chocolate chip cookies and how different ingredients react during baking.
First, the wet ingredients like butter, sugar, and eggs are added. When butter and sugar are mixed together, air gets trapped inside, which helps make the cookies softer. Sugar also affects how the cookies spread and brown in the oven. Eggs act as a binder, holding the ingredients together, and they add mixture to the dough.
Next, the dry ingredients like flour, baking soda, and salt are mixed together. Flour provides structure because it contains proteins that form gluten when mixed with liquid. Baking soda is a chemical leavening agent, which means it helps the cookies rise when it reacts.
When the cookies are placed in the oven, heat causes several chemical reactions to happen. The baking soda reacts with the acids in the dough and produces carbon dioxide gas, which creates air pockets and makes the cookies rise. As the temperature increases, the proteins in the eggs and flour begin to set, giving the cookies their final shape.